Greetings, scholars. I hope you all are well. I hope you all are safe and staying warm in this inclement weather. I want to record, first off, I'm going to record the last part of chapter one. This is kind of the introduction to statistics. And so we'll finish up with unit 1-4, statistical notation. So we'll walk through some of the notations that we'll see for the remaining of the semester. Be familiar with everything that you see moving forward, because this is kind of the foundation, kind of the bedrock of statistics and how we'll move forward with learning formulas and being able to identify how to solve certain problems that we were presented with. And we'll talk through a few things going into chapter two, but I want to complete chapter one, and then I'll record a separate lecture for chapter two in its entirety. So be on the lookout for those. So when we think about statistical notation, the statistical notation, these are kind of the language that we are writing, right? And so when you think about the English language, you can write the good boy is doing well, right? But and anybody in the United States, anybody that can read English will understand that and be able to read that. In statistics, there are notations that we use that are universal, that anyone in the world can understand. So we'll talk through some of these notations. We'll talk through the summation symbol. We'll talk about X and Y and all these other things that are universal to statistics and how we use and utilize statistics. Again, statistics uses operations and notations you have already learned. So we'll talk through that. So you know what the summation symbol looks like. Many of you, if you've taken algebra, you know what X and Y looks like. And some of these things that you'll see below on the second bullet says these specific notations are used most often and more common in statistics. So scores are referred to as X and or Y, depending on what we're gathering. So we talked about last class correlational data. So you'll have one variable that's your X variable, you have another variable that's your Y variable, and then you can kind of compare those two variables to see what the correlation is between those two variables. You have big N, which is the number of scores in a overall population, and then you have little n, which is identifying the number of scores in your sample. Let me get my pointer so that we can kind of talk through that. Okay, let's go back. All right, so again, you have little n here, number of scores in your sample, big N, number of scores in the population. We'll talk through being able to identify. Usually, when you get a problem in homework or on a quiz or on an exam, they'll identify, what we're looking for. Are we looking for the population or are we looking for the sample? And if they don't give you or specify specifically what the sample is or what the population is, if you look at the notation, this should indicate if we're talking about a population or a sample. Okay, so the summation notation, one of the most important that we use over the course of the semester, but many procedures that we talk about use the summation symbol where we're having to add up or aggregate a set of scores. And so when you are calculating your average, we talked about that. You have to add up all your scores, and then you divide by the total number of scores that you have in your sample or your population. So with this summation sign, this is what we call sigma, uppercase sigma. So this stands for summation. So whenever you see the uppercase sigma, you know that they're talking about summing or adding things together. Okay. The summation symbol will always be followed by a symbol or an equation that you must use. Okay. And it defines what is to be summed, either a group of numbers or a equation that we're going to use to sum. Summation is done after parentheses, squaring, multiplication, and division. So when you think about the order of operations, parentheses, exponents, when you think about multiplication, division, then addition and subtraction, summation comes after, again, in order, those particular order of operations, those particular operations, excuse me. Okay. So when you think about summation, with the summation symbol, be mindful of that. Give you some practice problems here moving forward after this slide, so we can practice getting the correct answer. Summation is done before either addition or subtraction. So I'll identify, give you an example, and demonstrate this in the next couple of slides. But again, these are two rules that you should be familiar with, specifically this order of operation. So when you think about please excuse my dear Aunt Sally, you have parentheses, exponents, multiplication, division, addition, and subtraction. And so these summation symbols are going to fall after those other operations. All right, so here's a check. Using those two rules that we learned about, please excuse my dear Aunt Sally, or the order of operations, and then all of your summation symbol is going to come before um, any other addition or subtraction. So if you're looking at this particular example, it says the summation symbol, you have x squared plus 47. And this is going to instruct you to do what? You can pause the video to think through this. But again, you should get that you're going to square each score, add up the squared scores, and then add 47 to that sum. That is what you're doing specifically here. So you're going to square each of the scores, right? Whatever those scores are, you're going to sum all of those squared scores, and then what you're going to do is going to add the 47 to the sum of that aggregate of those scores that you added up. Okay, so that is B. All right, here's another learning check. Okay, deciding which one is true or false. So the first bullet says the summation of sum squared. Is this equivalent to summing all your x values into the square? In that particular case, that is going to be false. Okay, because these two notations are two very different answers or solutions. Okay, and I'll demonstrate as we move forward. True false says that these two expressions are equivalent, and that is true. So when you look at this, yeah, all you're doing is you're multiplying the sum of this value and the sum of x for 2, and then you multiply those two sums together. Okay. And again, we'll walk through a couple examples so that you get a better grasp of these notations. All right, so here are some problems that you can practice. Okay, so for the first one, you're going to sum all these scores up. All right, so 4 plus 2 plus 6 plus 3, that's 9, 11, 15. All right, for this one, you're going to square every score. Right, square every score, and then you're going to sum. So 4 squared is 16, 2 squared is 4, 6 squared is 36, 3 squared is 9. You're going to add all of those up, and you should get your score. Okay, we're going to give you some time. You can pause the video, and then we will move forward. But actually, let's go ahead and let me get some paper, and we can go ahead and let's do this really quickly. All right, so what I'm going to do here quickly, let me share. And I want you to write these down. Pause the video, write these down. I'm going to switch over to my whiteboard real quick, and then I'll solve these out for you. Okay, the solution will be on the next page. All right, so let me go ahead and erase this first, and then we'll go ahead and start. So, all right, so we got our x values here. I'm going to rewrite these. 4, you got 2, 6, and 3. Okay. All right. So the first one is the sum of x. Okay. So with the sum of x, all I'm doing is I'm going to sum all these up. So that's 4, 2, that's 6, 12, 15. That should be 15. Okay. All you're doing is adding up all those x values. Okay. 15. All right. Number 2. This is the sum of x squared. So essentially all you're going to do here is you're going to square every value. So this should be 4 squared plus 2 squared plus 6 squared plus 3 squared. Okay, so all I'm going to do here is 4 squared is 4 times 4 is 16. 4, 36 plus 9. Okay, so if you want to add those up, you're going to get 16. Using my handy dandy calculator here. So that's going to be 16 plus 4 plus 36 plus 9. That should get you 65. Okay. All right. Number 3 was I'm opening parentheses and taking the sum of x and I'm going to square that. Okay. So essentially what this is, I'm taking this value, the sum of x, which is 15. So it'd be 15 squared, which is just going to give me 15 times 15, which should give me 225. 15 times 15 should give you 225. Okay, so that is number 3. Number 4. Number 4 is you're taking the sum of x minus 3. So essentially what this is going to be, this is the sum of x. So the sum of x, we already have that up here, which is 15. Okay. And again, like we said, one of the rules, you do the summation before you do any other addition or subtraction. So what we're going to do here, we already did our summation. We sum them all up, that's 15. And that 15 is going to be minus 3. And that should give you 12. Okay. So that's 1, 2, 3, and 4. And then the last one is number 5. You got sum x minus 3. Okay. So essentially, this is how you're going to write this one out. You're going to open parentheses. It's going to be 4 minus 3, close parentheses, plus, open parentheses, 2 minus 3, plus 6 minus 3, plus 3 minus 3. All right. So if we move down, you should get 4 minus 3 is 1. This would be minus 1. So 2 minus 3 is negative 1. So what we can do is we'll just do this. This is negative 1, close parentheses, plus 3, plus 0. All right. So if you add all these up, that'd be 1 plus a negative 1 is 0, plus 3 is 3, plus 0 is 3. So that should be 3. Okay. So those are how you solve all of these different problems. Okay. So this is the summation, using the summation in order to find the solution to these problems. All right. All right. So let's go back to my slides. Okay. All right. So those are the solutions to those problems. Here, if we move to the next one, next slide, I've already got those for you. So you should have gotten 15, 65, 225, 12, and 3. Okay, and I showed you how to solve those out. All right. So that is the end of chapter 1. Very, very straightforward. As we move forward, again, these notations are going to be really important that you understand what the summation symbol is, how to use the summation symbol. But again, very, very easy, very, very simple, but it can trick you up if you don't know how the rules of using the summation symbol. Again, please just use my dear Aunt Sally, use it in your operations, and then whenever you have any other addition or subtraction with a summation symbol, you do the summation first, and then you do everything else after that. Okay. Well, you all have a good one. We'll continue with chapter 2. This is frequency distributions. As we move into frequency distributions, we'll start to learn a little more about what the summation symbol is, how we use the summation symbol, because we're going to see it a lot more. Okay. We'll see you all soon.